Griffin, was that you who asked a question? Or Daniel, that was you. Which problem? 24? 44. All right, on 44, so what we'd want to do on 44 first is we want to divide both sides by that 2, right? Okay, so let's do that. And that gives us the log of 2x plus 5 is equal to 2. Okay, so now we want to write this in exponential form, right? But what's the problem with that? The problem is that we don't know what our base is. Or do we? Right. If there's no base there, it's understood that it has a base of 10. So there's a little 10 here. Can we now write this in exponential form? Yes. Okay, so that would be 10 to the is equal to 2x plus 5. All right, what's 10 to the second? 100. We'd subtract 5, divide by 2, and end up getting x equals 47.5. Is that correct? Any questions? Please raise your hand if you have another question from your homework. Any other questions from the homework? Yeah, like, did you want to do like number 45? Yeah. Okay, good. We divide both sides by 4 and we get e to the 3x minus 1 is equal to 1. That's not true. Is equal to 1.5 because 5 divided by 4 is 1.5. You meant 1.25? Yeah, that's what I meant. Yeah. Okay? Chloe. Okay, so now we're going to take the natural log of both sides. These cancel, and we're left with 3x minus 1 is equal to what? Natural log of 1.25, anyone paying attention at all? Yes. I'm sorry? 0.22? Is it 22? I think it is, right? Then we get 3x is equal to 1.22. I don't know why this is not working, sorry. Divide by 3 and we get x equals what? Good. Any questions on number 45? Yes, ma'am. Natural log, I think it's right underneath the log button on the left side. Yeah. Good. Other questions? 47? Okay, is 47 the problem we did not do yesterday? Okay, I'm sorry. It was in the homework? Oh, yeah, we're going to go over that in just a second. Are there any other questions from the homework? Any other questions from the homework once, going twice? Okay, let's start talking about these rational functions. Okay, guys, remember, who can tell me like kind of what you remember about rational functions? Anyone? Like what they look like? Jada? You have one on each side. Right. Okay. Yes, you're right with that. And remember, we have like those vertical and horizontal asymptotes, and then you're right. Like the graph's a reflection of itself over that. Correct. So this is already in the standard form, which is y is equal to a over x minus h plus k. Okay, and this is nice. These problems are very nice. 47 and 48, we like these problems, okay? Because the vertical asymptote is just x is equal to h, and the horizontal asymptote is just y is equal to k. So there are no holes because we can't cancel anything else out, right? And the vertical asymptote is x equals 2, and the horizontal asymptote is y equals 1. Do y'all remember that? Yes? Okay, now do y'all remember how to graph this? Well, let's go ahead and graph our asymptotes first, please. X equals 2. And then we have y is equal to 1. Okay, and then we're going to graph, we need to make a table. And what points go in our table? Well, we actually just pick, we can't pick our h because our h is an asymptote, which means it's not going to get there, remember? So let's pick a number less than that and a number greater than that. So a number less than our vertical asymptote would be 1, and a number greater would be 3. Good. When you plug in 1, you get 3 divided by -1 is -3, and then you get -3 plus 1 is -2. And then you plug it at 3, and then you get 3 minus 1 is 1. This would give you 4. So we just plot these. You go over 1 and down 2, over 3 and up 1, 1, 2, 3, 4. Okay, and then we just graph this. Oh. You know what it's supposed to look like and not cross that line? Any questions here so far? Now our domain is going to be -infinity. Okay, this is not working. -infinity to -infinity to 2, and then 2 to infinity. And then the range is -infinity to 1, and then 1 to infinity. Are there any questions there? All right, any questions? Okay, let's, I'm sorry, I'm having some technical difficulties, so I'm going to have to switch over to the document camera. All right, let's look over on 49. Okay, on 49, the first thing I'm sorry, actually we need to do these other ones first, I'm sorry. I want to start talking about the holes, vertical asymptote, and horizontal asymptotes. We kind of started this yesterday. Do y'all remember? Yeah. Did we go over all 3 of these yesterday? We did? So, okay, do y'all want, let's look at these quickly. On number 56, are there any holes? Are there any holes? No, nothing cancels out. Vertical asymptote is what? X equals 2 and x equals -2. And what about the horizontal asymptote? Y equals 0, okay? We went over these 3 cases yesterday too, didn't we? Yes? Okay. The reason it's y equals 0 is because the degree of the denominator is greater than the degree of the numerator, which means the horizontal asymptote is y equals 0. The vertical asymptote we found by just setting the factors in the denominator equal to 0, right? Do you have any questions about 56, 57, or 50, or 58? Any questions? Yes, ma'am. Uh-huh. Well, the degree of the denominator is equal to the degree of the numerator. So what happens when the degree of the denominator is equal to the degree of the numerator? The coefficients, right? And what's the coefficient of x of both of these? Would just be 1. So your horizontal asymptote would be y equals 1. Does that make sense? Good question. Other questions? Okay, let's go back to 49 because we're going to have to know that to do number 49. First thing I'm going to do is factor that. How do we factor the numerator? Difference of squares. Good. X plus 2 and x minus 2. And then in the denominator we have x plus 2. Do these two cancel out? And we're just left with y is equal to x minus 2. But what do we do with the factor that we canceled out? We set it equal to 0. So the factor we canceled out is x plus 2. And you were also right, Daniel, it is a whole. That gives us x equals negative 2. So our whole is at negative 2. And then our vertical asymptote is what? Do we have one? No, because there's not a variable in our denominator, so there's no vertical asymptote. There's no number we're going to be able to plug in here that will make the denominator 0 into y equals x minus 2. Okay? So what about the horizontal asymptote? What's the degree of the denominator? It's less, right? Because there's nothing there. There's just a 1, which means if there was a variable there, it would be x to the 0 power. And do you see how 0 is less than 1?
Yeah.
So that means that there is no horizontal asymptote. And ladies and gentlemen, the line y equals x minus 2, I just gave you the answer. Y equals x minus 2 is what? A line, right? We know that. We know how to graph it. So we just go to negative 2 and then the slope up 1 over 1. Up 1 over 1, up 1 over 1. We can go down 1 over 1, okay? Until we get this graph right here. Okay? Now, what am I forgetting? A what? A whole. Our whole is at negative 2. So we follow our graph and we say, okay, x is 0, x is negative 1, x is negative 2. This right here is where our whole is. And I'm going to draw a hole there. Do you guys see? What just happened? Sorry. Do you see the hole?
You have it in between.
Our hole is right there where the x value of our graph is at negative 2. All right, what is the domain? Negative infinity to negative 2, and then negative 2 to infinity, right? And our range is unrestricted, negative infinity to infinity. Are there any, well, our x value can't be equal to negative 2, but that doesn't impact the range. Does that make sense? Because think of it this way, Daniel. When we plug in negative 2 for x, at that one place from our original equation, then the y value is undefined there. So we would, what would we say? Negative infinity to undefined and undefined to infinity? You see what I'm saying? Yeah, okay. So yes, it's all real numbers there. Okay. So let's continue. I want to do one more like this. The whole is only the x value that it can't be there. Okay. Let's continue. Now on number 50, what we're going to have to do, and it's kind of ugly, is we are going to have to use the trinomial method twice. And like not the shortcut method. So it's going to get kind of, it's just a lot of work. Are you ready? Multiplies to give us negative 12 and adds to give us 1. What are those two numbers? Negative 4 and 3. Do you guys agree? Okay, now we're going to have to factor this out by grouping. So take out your GCF. That's a negative 3. All right, so our final two factors are going to be 2x minus 1 and 3x plus 2. Okay, the next thing we're going to do is factor out the denominator. But on the denominator, we're multiplying to equal 30 and adding to equal 17. Can we think of those two? 15 and 2? So that's just 3x squared plus 15x plus 2x plus 10. So these are two factors in the denominator. All right, so do we have any wholes, ladies and gentlemen? Yes. The 3x plus 2 and the 3x plus 2 cancel. And if we set 3x plus 2 equal to 0 and we solve, then our whole is at negative 2/3. So this is our new rational equation, y equals 2x minus 1 divided by x plus 5. And only at this point, after we've already identified our wholes, are we allowed to start identifying our vertical asymptote. To define the vertical asymptote, you just let your denominator equal to 0. So that would be x plus 5 equals 0, which means x is equal to negative 5. And the horizontal asymptote, if the degree of the denominator is greater than it is 0, the degree of the denominator is less than it is, there is not one. And if the degree of the denominator is actually equal to the degree of the numerator, then the horizontal asymptote is equal to the coefficients of the numerator and denominator. So which one is it?
Because it's
Yes.
equal to the whole.
It's y equals 2, because it's equal, I wrote 2 and okay, y equals 2, because both of our variables have the same exponent, so they have the same degrees. And since they have the same degrees, it's the coefficients, which would be 2 over 1, which is just 2. Do y'all see that? Any questions there? All right, so now we're just going to graph our asymptotes, which are at x equals negative 5. 1, 2, 3, 4, 5. And y equals 2. All right, the negative 5 would be negative 6, and a number greater would be negative 4. When you plug in negative 6 and you want to plug it into our final equation, I'm kind of running out of room, but that would be that would be 2 times negative 6 minus 1 divided by negative 6 plus 5, which is negative 13 divided by negative 1, and that would give us positive 13. Correct? And then when we plug in negative 4, I'm going to do it up here just because I'm running out of room. 2 times negative 4 minus 1 divided by negative 4 plus 5. That's going to give us negative 8, negative 9 divided by 1, which is negative 9. I know what you're thinking. You can't plot the point negative 6, 13 because it's off the graph. And it's fine that it's off the graph. I really just want to know if our graph is going to go like this, boom, boom, here and here, or like this. Do you see what I'm saying? It's either here and here or here and here. 1 and 2 or 3 and 4. Do you see that? Do you feel like you're at the eye doctor? Nobody got that. Negative 6, negative 5, negative 6, 13. So we know that it's going to be here and here, so it's going to look like this, something like this. And then we'll go to negative 4 and negative 9. And again, our graph is going to look something like that. Maybe, right? I'm not going to be particular. It's fine if it goes off the graph. I just really want to know that you know that they are here. Your graph is here and here in the bottom right and top left. So we've almost forgot to identify our whole, which our whole is at negative 2/3. So I'm going to follow our graph, and our graph is at negative 2/3 about right here. And I'm just going to draw a little hole there. Do y'all see that? The domain you need to write really, really small. Negative infinity to negative 5. Negative 5 to negative 2/3. And negative 2/3 to infinity. The range would be negative infinity to 2, and then 2 to infinity. Any questions? Yes, ma'am. Is it emergency? Any other questions about this problem? All right, we really need to start trucking on if that's okay with you guys. The other two are very similar. Look at number 59. All right, on number 59, we need to have a common denominator, so that means we need to multiply our numerator and denominator by what? By what? Right? Good. We wanted a common denominator, and our common denominator would be 18x. So that becomes 15 over 18x plus 7x over 18x. And then we could just add these together, but not really because they're unlike terms. And we get 15 plus 7x divided by 18x. But guess what? X cannot be equal to 0. And we're done. Any questions? That was an easy one. We like those, right? All right, let's look at number 60. On number 60, we need to go ahead and factor out. I'm trying to leave that so if y'all are still writing it down. On number 60, we need to factor this out, right? So on number 60, we need to find two numbers that multiply to give us what? Multiply to give us negative 6 and add to give us? Good. What are those two numbers? Negative 3 times positive 2? Cool. Are y'all cool with me just like rewriting this as x minus 3 times x plus 2? Now, that means that this guy over here needs what in its denominator? He needs an x minus 3 too. If he gets an x minus 3, I want an x minus 3 too. So now we can rewrite this as x plus 1 divided by x minus 3 times x plus 2 plus 5x minus 15 divided by x minus 3 times x plus 2. So then this will be 6x minus 14 divided by x minus 3 times x plus 2. Now guys, before we get crazy by before we try to cancel anything else out, what do we need to identify? Our restrictions. Very good. And that means we're just going to set the denominator equal to 0, so x cannot equal 3 or negative 2. Then we can go back and try to simplify this, but even if we factored out a 2, we're not going to be able to simplify. So this is our answer. These guys together. Any questions? I know that I'm going fast, but awards day, I guess I will see you guys on awards day, won't I? We don't have class?
We don't go to only freshmen electives go.
Excuse me. I'm sorry, but I think that we're going to come back here after it, so I'll still get to see this class on Thursday. Okay? So maybe I don't have to panic as much with you guys. But let's still continue to go through this because even with that Thursday, we still have a lot of ground to cover, okay? All right, so would y'all like to see number 61 or 62? 61. Do you want to see 61 just because you think it looks scary? All right. Hey, I'm just wondering. Of course I'll do it. I just was being curious, okay? So how do you factor x squared minus 25? X plus 5 times x minus 5, okay? Now, remember when we're multiplying when we're dividing by a fraction, it's the same as multiplying by its reciprocal, right, Sam? So I'm going to, we're going to move this guy up here. And this just becomes 2 times x squared plus 3x minus, is that a minus 10? How do we factor that? two numbers that multiply to give you negative 10 and add to give you positive 3 are x plus 5 and x minus 2. And then I'm going to factor this to get x plus 6 and x plus 4. And 4. And the reason I switched these two is because we're multiplying by the reciprocal. Do y'all remember that? Any questions on what I've done so far? Please let me know. Please don't be afraid to ask a question. All right, so now we're going to simplify this. We've got, oh, what do we need to do before we simplify? Oh, thank you. I don't know why I put 4, thank you. So we need to identify restrictions. X cannot be equal to negative 5, positive 5, negative 6, or negative 4. And then we can simplify. We've got a 5, 5, 4, 4, and we're left with 2 times x minus 2 divided by x minus 5 times x plus 6. So this guy and this guy is part of our answer. Do you guys have any questions? All right, what problems do you guys want to see from 62, 63, 64? What are you thinking? What'd you say? 63? Okay, on 63, and I'm going to leave this up here and I'll kind of try to write so you can see it. 2 minus 3x is not equal to 3x minus 2, okay? If we wanted to rewrite this one, this 2 minus 3x, how could we rewrite that? With the 3x in front, how would we write that? Right, this is the same as negative 3x plus 2. So this is not true, but this is the same as that, right? So what would I need to do to this negative 3x plus 2 to make it match this 3x minus 2? Very good. Multiply it by negative 1. Negative 1 over negative 1. We end up getting negative 1 over 3x minus 2 plus 5x over 3x minus 2. So we can just combine our, or really we can't combine our like terms because we don't have any, but we'll end up getting 5x minus 1 over 3x minus 2. Oh, I'm sorry. I'm so sorry. Thank you. Can we simplify that? Well, if we could simplify it, we would simplify it, but we can't simplify it. How would you propose we simplify it? We can only simplify if its multiplication is occurring. For example, if this said x times 5x plus 1 over x times 3x minus 2, okay? If these x's were out here and they're being multiplied, then we could cancel out the x's, but we can't cancel them out here.
So would you simplify for 62?
No, you can't simplify for 62. You'll just get like that, what does it end up being? 5 minus x cubed over, if the x cubed were able to pull out, then we would simplify, but you can't. I understand what you're saying because in the denominator, the x squared right here is outside, so it's being multiplied, but up here, it's just the x cubed. When we get our answer here, we end up getting x cubed, 5 minus x cubed, right? And that's over x squared times x minus 2. And he was saying, can we simplify? Do y'all see that? Yes? Yes? Okay. Any other questions here? Okay. Let's turn over and let's look at, these are all the same equations, really. And then we know how to do this. It's just a bunch of factoring, right? This one we know how to do. It's multiplying by the reciprocal. Let's talk about problems like these equations. We need a common denominator, right? So what do we need to multiply this first one by? 2 over 2, and over here it's, so then we get 8 over 2x plus 5x over 2x equals negative 11 over, I'm sorry, negative 22 over 2x. Do y'all remember what we can do now? We could, the denominator you mean. Right, I'm sorry. It's okay. So we get 8 plus 5x equals negative 22. 5x equals negative 30, and x is equal to negative 6. Any questions? Okay, let's look at a problem like 72. All right, on 72, we need to multiply by what? Right, and I only have to multiply this one guy by x plus 2, correct? It's hard to fit that in there, but it gives us x over x plus 2 plus x times x plus 2 divided by x plus 2 is equal to 5x plus 8 divided by x plus 2. So what can we do with all these x plus 2's? They go away, right? They cancel out. So then we get x plus at this point, I'm just combining my like terms, solving, and getting one side equal to 0. So that's x squared plus 3x equals 5x plus 8. Now we can subtract 5x and subtract 8 from both sides, and we end up getting x squared minus 2x minus 8 is equal to 0. At this point, we have to factor and solve, right? So our two factors are x minus 4 and x plus 2, because those are the two numbers that multiply to give you negative 8 and add to give you negative 2. Then we'd set both of those factors equal to 0, and we'd get x equals 4 and x equals negative 2, assuming that we don't have any extraneous solutions. In order to determine this, what we need to do is go back to our original equation and plug in both 4 and negative 2. Okay? You can do this all in your calculator, but once you plug in the 4 for the x, you'll see that 4 does work as an acceptable solution. But when you plug in negative 2, what will you get in your denominator? And that's so undefined, so that's not an answer. That is an extraneous solution. You need to identify some way by pointing and saying this is extraneous or xing through it what an extraneous solution is. Are there any questions? Questions? Okay. So these are the same thing, pretty much, just common denominators.
Yeah.
Okay, let's talk about this really quick. I really wanted to get to trig today, so bear with me. All right, on this one, we would draw the unit circle, remember, and then we'd identify these values, these exact values. We're not going to have time to draw the entire unit circle, and some of you at this point may not even have to draw the entire unit circle because you've probably gotten it really down pat as much as we have been looking at it. So if it says the tangent of 7 pi over 6, we can convert that to degrees. What? On number 75, we can convert that to degrees. And what do we get? 210. So this is the same as the tangent of 210 degrees. Did somebody already say that?
Yeah.
I didn't. I heard you say something, and I asked you to repeat it because I didn't understand what you said. Do you remember?
Yeah.
What? What?
Yeah, I remember
Thank you, Alexia, for letting us know that the answer is 210 degrees. Okay, so at 210 degrees, Alexia, can you tell me where that is? You ready?
That's 90, that's 180, that's
Oh, right here. And do you remember what the coordinates are at 210?
negative square root of 3 over 2 and negative 1.
Perfect. The tangent of 210 degrees, that is very good, is sine over cosine. In this case, that's negative 1/2 divided by negative square root of 3 over 2, right? So now we got to multiply by the reciprocal. We are so not allowed to have a radical in our denominator. It's totally irrational. So we get the square root of 3 over 3. Any questions? Do we remember this?
Yes.
This is fresh on our brains, right? More fresh on our brains?
What was like spring?
Right, that was not that long ago.
What was like March?
Okay, sine of 225. Where's 225? 90, 180, 225. And do y'all remember the coordinates?
Yeah.
Negative square root of 2 over 2 and negative square root of 2 over 2. Very good. So here at 225 degrees, the sine is just negative square root of 2 over 2. Oh. All right, 270, we go 90, we go 180, we go 270. We're here. What are the coordinates here? 0, negative 1 are correct. And the cosecant is 1 over the sine. Remember, s goes with c and c goes with s, so it's 1 over the sine. Sine goes second, so that's 1 over negative 1, which is negative 1. Any questions here? All right, cotangent of negative 5 pi over 6. What is negative 5 pi over 6? 210, but we're actually not, it's not this same 210. Are you sure it's 210? Okay, when you put in your calc, but what do you get for that? You get negative 150? Okay, 210 might confuse people because they might try to go 210 the opposite way. Does that make sense? You're not wrong. But I'm just saying that this is the same as the cotangent of negative 150, which means we're rotating this way 90, and then we rotate another 60, so that's negative 150, which is a positive 210 as Daniel had stated. So this is equal to the cotangent of positive 210, which the cotangent is the cosine over the sine. So at 210, the cosine is negative square root of 3 over 2 over the sine, which is negative 1/2. We multiply by the reciprocal, and we get negative square root of 3 over 2 times negative 2 over 1. The negatives cancel instead of the 2's, and we just get the square root of 3. What? I'm sorry.
Spell it first.
Do you have any questions? I'm going to let you have this time for questions because your homework for tonight is going to be 1 through 84 or whatever you haven't finished. Please do not pack up yet. We still have 4 minutes. It is not time to pack up. I need you to ask me questions. We're still recording, so just raise your hand if you have a question. 1 through 84. Raise your hand if you have a question.
Was that last problem negative square root of 3?
No, it's positive because since it's in the third quadrant, it's a negative and a negative.
Yeah.
Raise your hand if you have a question. Please remember the last day that I will have tutoring after school is Thursday. That means you have today after school, Wednesday after school, and Thursday after school. That's only 3 days after school. If each and every one of you wait until Thursday after school to come for tutoring, you will not get nearly as much individual help as you would like. Is that clear?
Yes.
So please do not wait till the last minute. I will probably not have another opportunity to offer you tutoring other than Thursday. Please stay in your seats. Please stay in your seats.